Assalamu alaikum class. Bismillahirrahmanirrahim. Today we are on our 11th lecture and this will head on 30th of January. Course is Operation Research and we are now on the going model and the topics under discussion relating to the Coing model will be the elements of a Coing system or process, input process, service mechanism, distributional of arrival and service time, birth death process, single server model, and multiple server model. Book will be the Gupta and Hira that is published in 2015 on the operation research and fifth of edition. And the website relating to this chapter where the solved questions are available is its link is given. And you can also consult your textbook of Hamdi H. Taha. Actually, till now we came to know that the operation research was started when there was a World War II, and its basic purpose is to find the strategic and technical solution of the problems that are involved in military operations. And the objective and the problem's objective was to find the most effective utilization of limited military resources by the use of quantitative techniques. Following the war, numerous peacetime applications emerged, leading to the use of operation research and management science in many industries and occupation. So basically, nowadays, this course or this system of studies or system of analysis or finding the solution is about finding the optimal feasible solution of our objective function, and the objective function will be of maximization type or minimization type. Maximization may relate to the profit, or minimization relates to the cost and the time and so many other problems that can be solved. So basic technique behind the operation research is that we have to formulate first problem. Formulation means that we have to define our variables, we have to define the problem, and then we have to build a model. Model building means that we will use the quantitative techniques, some operators, some operands, and we use the variables to clear the picture and finding the solution. So basic problem here is to use the quantitative techniques to formulate the problem and also to find the basic feasible solution. Till now we find out that if there are two variables, then the graphical method is the technique that can be used to find the solution, and if the variables are more than two, then we use the other methods, from which simplex method is the basic method. In simplex method, we find out the solution with the help of iterations. And when we find out that there is no negative or zero value in the solution set, then we can say that it is the optimal feasible solution. Then in simplex method, we have the other techniques and the derivation relating to it. Then after simplex method, we have also came through with the integer programming. Here, instead of variables, we whole numbers, we have the integers. Maybe instead of 4x, we may deal with the problem of 4 over 6x, or maybe 4 over 7x. So there are integers into our programming, or into our defining the variables, or defining the problem, or formulating the mathematical model. Then we have the also go through the advanced programming. In advanced programming, instead of these equations, we have the problem in form of the matrix form. First, we formulate the matrices and then we find their solution. We also go through the transportation problems, and in transportation problems, we can solve them with the help of least cost method, northwest corner rules, and by a Vogel approximation. And the transportation is only the problem of minimization. And then we also find out their optimal solution, whether the solutions are optimal or not, and with the help of Modi method and stepping stone method. And in our last lecture, we go through with the advanced linear programming and the integer programming, and also simulation and the techniques relating to the simulation. So simulation is the process of generating the data or generating the real situation instead of the artificial variables or artificial solution. So this was all relating to the operation research that till now we go through with the syllabus. Today, our topic is relating to, first we will see the models. So models in the operation research are of the different type. A model is a systematic description of a system theory or phenomena that accounts for known or inferred properties that may be used for further study of its characteristics. So the system may be functionally related group of elements, or it may be human body regarded as a functional psychological unit, or it may be an organism as a whole, or we can also say that a group of physically and complementary organs or parts, or some mechanical or electrical components, and a set of structures and channels and a network of related computer softwares. So all this belongs to the system, and the systematic description of these system or theory or phenomena is known as a model in operation research. So operation research is the study of mathematical models for complex organizational systems, and finding basically operation research is a course or research study to finding the optimum solutions relating to the problems or the branches of operation research. And the optimum solutions relating to the branches of operation research may be the mathematical techniques, or such as the linear programming, non-linear programming, advanced programming, integer programming, and all these programmings or systems, or we can say the techniques, are used to find the optimal feasible solution. So models in the operation research are linear, and they are the models of network flow programming models, and also integer programming models, non-linear programming models, and the dynamic models. So the dynamic programming model describes a process in items of states, decisions, transactions, and returns. The process begin in some initial state where a decision is made. The decision cause a transaction to a new state based on the starting state, ending state, and decision return is realized. So then we have the stochastic process. In many practical situations, the attributes of a system randomly change over time. For example, including the number of customers in a checkout line, and the model is described in part by enumerating the states in which the system can be found. The state is like a snapshot of the system at a point in time that describes the attributes of the system. So then we have the Markovian chain, and the Markovian chain models are the shows the stochastic process that can be observed at regular intervals, such as every day or every week, can be described by a matrix which gives the probabilities of moving to each state from every other state in one time interval. Markov process, a continuous time stochastic process in which the duration of all state changing activities are exponentially distributed. Time in is a continuous pattern. The process is entirely described by a matrix showing the rate of transaction from each state to every other state. Then we have the simulation. It is often difficult to obtain a closed from expression for the behavior of a stochastic system. Simulation is a very general technique for estimating statistical measure of complex system. So then we have a time series and forecasting models. A time series model is a sequence of observation of periodic random numbers, typically serve as input to ORDCN models. And their examples are given in the slide. Then we have the inventory theory models and reliability theory models. So inventory theory models are the basic topic of today's discussion. So inventories are materials stored waiting for processing or experiencing processing. When and how much raw material should be ordered is the inventory. When should a production order should be released to the plant? What level of safety stock should be maintained at a retail outlet? How is in process inventory maintained in a production process? And the reliability is to attempt is the attempt to assign numbers to the propensity of systems to fail. So mathematically programming means a mathematical model consists of decision variables, constraints, objective functions, parameters, and data. And its general form is given on the slide. So it may be of minimization or maximization function subject to the function or the constraints. Then the linear program LP is all function f and GI are the linear, and X is a continuous and integer program. X is discrete. So mathematical programming is a solution is an assignment of values to variables. A feasible solution, we find out the objective function value we have, and then we find out the optimal solution. So operational research is optimization of the problems and applications of personal examples. Example is given here and we are familiar with it. So you will go through it that the production requirements per day are given and the objective is to minimize the production cost, and the formulation of the linear programming is given over here that minimization is the objective function of 20x1 plus 15x2 subject to 0.3x1 plus 0.4x2 greater than or equal to 2.0 and so on. And then there we have to find out their graphical demo, and then we have to find out their basic feasible solution either with the help of graph or with the help of simplex method. So in integer programming, the convex hull of integer solutions, we have to find out the linear and programming realization, and then we have the x, the variables are discrete set of integers. So here is the example of integer programming. The linear programming based branch and bound. So here the programming problem is of minimization and subject to the constraint is given where a, b belongs to real numbers, and the p is the convex of x and ax. So basic algorithm approach use linear programming relaxation to produce lower bounds, branch using hyperplanes, and basic algorithm elements are given. So this is all relating to the topic of inventory models and the models in the operation research, branch and cut methods, and their relating the problem, and then the it's the common problem in operation research. Its model is given in the slides, and inshallah in the class we will go through it. So here is a dynamic load assignment problem of trucks to loads. So parametric multi The criteria objective is to early or late delivery or early or late pickup, reduction in empty travel vehicle maintenance schedule, drive vacation, driver horse balancing, and union labor, and this all is under the topic of this. So this was all relating to the slides.